everyone. Welcome back to another round of Turing Mock Interview series. I'm Jose, tech lead at Turing, and I'm from Montreal, Canada. And at Turing, I work on hiring the best engineers by helping them with the vetting process. I have more than 17 years of experience, and my expertise lies in JavaScript. Today, I will be interviewing Lau for the role of an experienced JavaScript developer. And if you go for any JavaScript tech stack, you might be passing by this interview, okay? Vue.js, Node.js, Angular, React.js. Before them, you have a JavaScript interview, okay? So let's hear from you, Lau. Could you please tell me a little bit more about your background, about your professional experience?
Yeah, sure, Jose. So regarding my professional experience, I have been working with JavaScript from last 4.5 years. And like in that experience, I have been working with the companies. I started my career in a local company where I was working with JavaScript frameworks like Node.js, Nest.js, Next.js. I have worked on front-end libraries like React.js as well. And with that, after like a couple of years, I realized that I should go ahead and start freelancing. And like in freelancing, I have worked on numerous projects with a number of clients where I've been building the different kind of dashboards, or let's say their products, which are like website builders, and different kind of their products which help them in predicting their sales or increasing their revenue.
Nice. Okay, so I see how you have been working hard, okay, until today. Could you please tell me just a little bit more about some interesting JavaScript project that you have worked on?
Yeah, sure. So regarding the interesting project I have worked, for me, it was a website builder, which I have worked for one of my clients, where we were providing an experience where users can just go ahead, drag and drop some elements, whichever they want, and that will just allow them to create the website they want. And like we are also providing them for deployment process, so they can just hit a button, assign their domain, and they'll be good to go. And apart from that, the other product that I have worked on was kind of an inventory management system, where the system was designed to predict the future sales for like the next quarter or next year, so that a company can decide how should and how much they should be producing for that particular products, because sales are depending upon the market conditions. And let's say if there is no sales, there is no need for more production. So I've been involved in those kind of projects moreover, and like apart from that, I have worked on different kind of dashboards that just shows different charts and stats to the companies so that they can decide how they want to proceed further.
Nice, really nice. And just a quick question before we move on. Okay, so in that project, okay, did you use any framework and library in JavaScript, or it was vanilla JavaScript?
No, for like website builder, we were using Monstack, basically Mongo, Express, React, Node servers. And apart from that, for the other projects, I have been responsible for the front end development, where I was mostly using React.js as a development environment. And apart from that, like different UI libraries like Material UI and Design, Tailwind, and some other UI libraries like Chakra, like we were using those.
Nice, cool. So thanks for sharing, by the way. Okay, so let's now move forward, go to the JavaScript question, okay? And my first question for you is JavaScript single thread or multi-threading?
JavaScript is a single threaded. So
single
basically,
thread.
Yeah, basically whenever like you execute your code, it is executed in sequence, and it doesn't execute in a parallel manner. So whatever operations you are doing, that will be executed in a sequential manner.
Correct. Nice. And okay, so JavaScript is single thread, correct. But how does JavaScript handle asynchronous operation, like promises, timers, set timeouts? How does JavaScript handle that?
That we have the event loop. So basically, whenever you are executing those kind of asynchronous operations, JavaScript maintains a call stack where all the calls you have made for different kind of functions or operations, they are maintained. And as soon as a particular function is finished, it is popped from that particular call stack. And if in the meantime a new function comes in, it pushes it into the call stack. And JavaScript maintains an event queue, So whenever, let's say you are executing an asynchronous code, and you have to like once that code is finished, event queue just registers next callback that is given to the call stack, so that you will have your asynchronous code executed, and in the meantime your next lines of code will keep executing.
Nice, good answer. But I'm curious about something. So you mentioned we have the call stack and we have the browser APIs, we have the event queues, right? So how JavaScript knows that a promise is ended to execute the callback?
Sorry, can you repeat?
Yes, how does JavaScript knows, okay, that the promises just finish or set timeout is ready to push in the call stack?
Okay, for set timeout, we basically use the timers, so that like you have the second argument as a timer, which you decide how long that particular function needs to wait before getting executed. So basically, as soon as you create your set timeout function trigger, it just creates a delay before that particular function call. And whenever you are going to execute asynchronous code with promises have like 3 states, basically fulfilled, if promise is rejected, or settled or not. So basically, based on those states, JavaScript decides like which callback function to execute at that point.
Nice. Okay, we're going back to promising later in this video. So, what do you understand about the event loop in JavaScript? What's the event loop?
Event loop is basically, let's say you have a couple of tasks ongoing. So for each task, you will have different kind of subtasks. So while you are executing a particular task, as soon as the subtasks come in, JavaScript just pushes it into the call stack. It just keeps executing the next function calls. And after that, it will just keep moving. Let's say if a function call has 4 sub functions calls, so call stack has those 4 functions pushed in. As soon as those functions are getting executed and finished, call stack pops out those functions, and event queue just keeps registering those functions, so that like it has all the all the execution details. And whenever, let's say, a function is finished, event queue responds back to a call stack, so that it executes the next relative function which is required to run.
Nice. Just to adding something on it. Okay, so the event loop is the one that's keep checking the event queue. So if you resolve a promise or a set amount, for example, you will push an event into the event queue, and the event loop is the one that keep constantly checking the event queues. So if there is any callback there, some callback there, the event loop will get that callback and push in the call stack, then JavaScript will execute. And we have several priorities for that, okay? So promises will resolve in the current execution of the event loop. Timers like set timeout, set immediate, process next tick, they all goes to the next loop, which means is if you have 10 promises will resolve, will be pushed first in the call stack, then a single set timeout. If you have thousands of promises resolved, thousands of promise resolves will go to the call stack, and then after that, the first set timeout will go to the call stack. Sounds good?
Yeah.
Nice, man. So now we're going to talk about promises. So what do you understand about the difference between promises and observables?
For promises, it's a single event that handles the asynchronous operation, which is like either completed or failed. Wherever, if you consider like promises can be used for basically asynchronous API calls, or let's say any asynchronous operations we are doing. For observable, it is kind of provide subscribers, so that let's say you have some sort of code that is being executed and you want other functions to be subscribed to it whenever that is being executed. So whenever a particular value or particular event happens, observable informs that particular function, subscribe functions, so that they can know that particular event or particular value has been triggered, so that the next operations can be made. Whereas like in promises, you will have like the then, catch, and finally blocks, which are executed based upon the promise state, whereas finally will be executed in all the state if like promise is rejected or resolved.
Nice. You did the homework, right? So you are quite good JavaScript, man. So thanks for your rich answer. So let's keep on promises. Okay. What do you understand about the difference in this kind of question? You face it in all JavaScript interview. Okay, what do you understand by the difference between promise.all and promise.all settled?
Okay, so promise.all, let's say you have a number of promises ongoing, and like as soon as one of the promises gets rejected, promise.all will just reject from there on. It won't like take forward. And if you have promise.all settled, that will never reject. It will resolve all the promises. So let's say if you have number of promises in that, you will still have the state of that particular promise and whatever the value that promise has returned. So let's say if it is rejected or resolved, you will have state and you will still have the whatever error value or resolved value that particular function has returned.
Correct. So if you have a promise.all and you have 3 promises and 1 promise was rejected, so all the promise will be rejected. And if you have a promise all settled, if one is rejected, it doesn't matter, the promise will keep going, and then you have an array with the results with failures and succeed. Is that correct?
Yes, that's correct.
Nice, great. So what are event emitters?
Event emitters, you can consider like, let's say if you have a function in which you want to trigger event manually, like we have the click event, double click event, likewise in Doom. But if let's say if you want to emit a particular event whenever a user logs in or something happens, you just want to trigger an event. So basically for that, we are using the event emitters, which fires a callback whenever a particular events are triggered. So you can just consider that as a publisher subscriber model, which is like whenever you publish an event, that subscriber to that particular event will just execute and listen to that particular event so that it can execute the code which you want to do on that particular event.
Nice. And could we like unsubscribe to event emitter? Unsubscribe. Can we unsubscribe?
Yes.
Okay. All right. So let's move on. What kind of optimizations technique, okay, are you familiar with?
For optimization,
yes,
I'm familiar with like caching or memoizing the function return values. So let's say you have a function calls. Just consider like I'll just explain with an example.
Okay.
So consider you have a recursive function for Fibonacci series. Now, like we basically do that with recursive functions just because we can memorize those values, so that whenever you are calculating values for next iterations, memoization or caching will help you to remember the old values of previous iterations. So if you are calculating a factorial for 10, you already have the calculation for factorial 1 to 9. So basically you can just reuse those values and you can avoid like the recalculation of those values, so that your functions can perform faster and you will have results in less time than what you are like expecting.
Nice example. All right. Yeah. Now, and okay, memoization is the one. And are you familiar with any other one?
Next is use of break, continue, and go to operations. So let's say if you have a for loop, which is like work like looping for lot iterations, and you have the like a number of designated conditions that in this case you don't need to execute any sort of code, or you want to break a loop in that case. So you can just use continue or break statements that will allow to reduce the number of iterations that you are going to execute for that sort of code, and it will just free or like it won't just complete whole loop. Let's say if you are using a break on a loop which is of 100 iteration, and you got the value which you are looking for at the 10th iteration, you don't need to iterate for next 90 times. So you can use break that. Nice. Now, let's say if you have same example and you want to use like you don't have the value which you are looking for, and next sort of code is not required, you can just skip by using continue statements. It will just skip over that particular iteration, move to next iteration. Whenever that particular condition satisfies, you can just continue the code which you need to execute. And for go to, like you will need to create labels, so that like if you want to jump over different code blocks, you can do that with like, let's say you have some sort of add, subtract, multiply, and division. Just consider like without switch case or any other code block, but you are just going to use labels there. So whenever you have taken the input from users, now you need to calculate based on the users button they have clicked, like plus, minus, division, or multiplication. So now you can just jump out of that code block. You can just go to that particular label where you have the code for addition, subtraction, or anything, and you can execute that code. Again, you can jump from that label to the next label where you want to execute the code, and you can return the value as you want.
Nice. Let me just write down this. Okay, so memorization, okay, and cache, you talked it earlier, and then use break and continue and go to. Okay, this is also good techniques for improve the performance of your function. Is there anything else?
Yeah. So third one is web workers.
Web workers, yes.
You can consider you need to execute some sort of asynchronous code in the background. So you would use web workers in that case that will allow you to execute that sort of code. After that, you will have an event as soon as the execution has been completed, so that your JavaScript code will come to know that execution is completed. If there is any next operation needs to be done by us, we can configure that and perform that operation. So that that will allow us to communicate between web workers and our JavaScript code.
Nice.
And
great.
Apart from that, I have one more that I used to do is avoiding memory leaks. Basically, memory leaks are basically needs to be avoided for any JavaScript application, or let's say any application you are working on. If you're doing development, you should not be doing memory leaks. So basically, I would avoid using global variables. I would just use function scoped, or let's say that particular class scoped variables, so that whenever I need to access that, I access that with particular instances, so that no variable values or no data is being leaked from that particular application. Apart from that, we have some let's say we have a set timeout set. We are doing that particular operation, and if we forgot to clear that timeout, if we have set time in set intervals, if we set intervals, it will just keep executing after each interval. So we need to avoid those kind of functions whenever possible, and if not possible, we can use them, but we should still clear the interval or clear that particular timeout functions. And moreover, I would say I perform the reusability stuff on my end. So let's say if there is a 10 or 15 lines of code that keeps repeating, I would just create a common function so that that can be reused for multiple times. And if it is used by multiple services or multiple components in React, you can just create some utility functions that can be reused for all over the code in your particular application.
Cool. I have nothing to add to it. Great answer. All right. So now I'll just give you a little break and call upon our developers here. So if you are enjoying this video, please consider subscribe to our channel and hit the like button and comment down below what you think about this interview. If you know the answers, okay, or if you are learning something new today, let me know in the comment section below if you are learning something new today, okay? And tell me in the comment section below as well, what kind of interview would you like to see in the upcoming video, because we're gonna make it for you, okay? So let's go back to you, Lau. My next question for you is, it's regarding the vanilla JavaScript, okay? So what's the difference between call and apply?
Call and apply. I would say call takes arguments separately. So whatever the number of arguments you have, you either need to pass them as different arguments. First argument will be the object where you want to apply, where you want to call the particular function, and next sort of all the arguments should be whatever the number of arguments you need to pass. For apply, you can directly use an array, so that there will be first argument is the object you need to apply on, and you will have that particular sort of array where you will have list of all the details which you want to perform there. So basically, in call, you will have number of arguments, where apply will have single argument with an array.
All right, got it. Okay, so let's see. What's the difference, okay, in your understanding about create an object using const and object.freeze?
Okay, for const, let's say you have created an object with const, you can't like reassign the value to that particular variable. But let's say if you want to update a particular field in that particular object, you can do that. Let's say you have object with user and you just have first name in it. Now, if you want to add user.last name, you can do that. If you want to update user.first name, you can do that. But let's say if you have freezed a particular object, and if you try to modify the inner fields, so let's say you freeze the user's object which has first name, and now you freeze it, you won't be able to rewrite the first name, or you won't be able to update the add the any additional field, let's say last name or age in that particular object.
Great. All right. So, okay. One more question, and then we're going to end this interview here because it's taking too long. So if you want to see the part 2 of this interview, please comment down below. I want to see the part 2 of JavaScript interview, and then we're going to make it. Okay. Hit the like button, comment down below. I want to see the part 2, and then we're going to come with the part 2 for you. Okay. So my last question, okay, for today, what's the difference between map and weak map in JavaScript?
Okay, map and weak map. For map, we have unordered list. So let's say we have a key value pairs where each key has the different kind of values, string, boolean, objects, or numbers. Whereas in weak map, we will have every key that is mapped, which will have at least like object references, so that objects and functions can be stored in it. Your like all the maps can be iterated. So if you want to iterate over all the values, you can do that. For weak map, you can't iterate over that. So you will need to like call that by using that particular weak map dot whatever the value you are going to call there. For maps, you will have everything, even if you can keep all the data there if you are not going to use that. And for weak map, it holds the references to the key. So like if you have stored a particular key, it will just store the reference for that. It won't be storing that particular function or object in it. It will still have the reference for that. And like garbage collectors doesn't remove a key pointer from map. So let's say you have stored data in map, that will still remain whenever garbage collector like executes, but your map doesn't remove that key from the memory. But if you are storing it in weak map, that will be removed whenever a garbage collector calls, and like it will just remove that particular reference from the key, so that like, at the end you won't have that particular value stored in your weak map.
Nice, really nice answer. All right, so okay, I think that's it for today. Okay, don't forget to subscribe to our channel, hit the like button, comment down below. I want to see the part 2. We're gonna make the part 2 for you, and I hope to see you again. Okay, take care. See you.
Thank you.